Python was created in 1991 by Guido van Rossum, a Dutch programmer who wanted to make coding easier and more readable. Unlike many programming languages that use complex syntax, Python focuses on simplicity with clean code that almost looks like plain English. This beginner-friendly approach made it one of the most popular languages in the world, especially for people just starting their programming journey. Python's strength lies in its incredible versatility. From data analysis to artificial intelligence, from web applications to automation scripts, Python does it all. Tech giants like Netflix use it to power their recommendation systems. NASA relies on it for complex calculations. Google built significant portions of their infrastructure with it. The secret? A massive ecosystem of libraries. Tools like NumPy for numerical computing, Pandas for data manipulation, and TensorFlow for machine learning mean developers can build sophisticated applications without reinventing the wheel. But Python isn't perfect. As an interpreted language, it sacrifices speed for simplicity. Performance-critical applications like game engines or operating systems typically look elsewhere. Memory consumption can also be hefty compared to lower-level alternatives. Born in 1972 at Bell Labs, C emerged from Dennis Ritchie's vision of a system programming language. Its original mission? Building the Unix operating system. That mission succeeded beyond anyone's imagination. Today, C forms the bedrock of modern computing. Windows runs on it, Linux runs on it. Even Python itself is implemented in C. That's how foundational this language is. What makes C special is direct hardware access through pointers. This low-level control enables highly optimized code, which is why embedded systems, operating systems, and real-time applications still depend on it decades later. The trade-off? Manual memory management. Developers must carefully allocate and free memory themselves. Mistakes lead to memory leaks, buffer overflows, and security vulnerabilities. Plus, C lacks modern conveniences like object-oriented programming and automatic garbage collection. In 1983, Bjarne Stroustrup had an idea. Take C's speed and efficiency, then add object-oriented programming features. The result changed software development forever. C++ became the language of choice when performance matters most. Unreal Engine? Built with C++. Chrome and Firefox browsers. C++. High-frequency trading systems where microseconds mean millions of dollars? You guessed it, C++. The language offers incredible flexibility, supporting both procedural and object-oriented approaches. Features like templates and the standard template library enable code reuse while maintaining peak performance. But this power comes at a price. C++ has a notoriously steep learning curve. Its complex syntax and inherited memory management challenges from C make it difficult to master. Even with modern smart pointers helping with memory safety, developers must stay vigilant. Large projects can suffer from slow compilation times and debugging nightmares. When Sun Microsystems launched Java in 1995 under James Gosling's leadership, they made a bold promise. Write code once and it'll run anywhere. Any device, any operating system. Just need a Java virtual machine. That portability transformed software development. Java became the backbone of Android, powering millions of mobile applications worldwide. Enterprise systems, banking platforms, and web servers all bet big on Java. Automatic garbage collection handles memory management, reducing bugs. Massive frameworks like Spring and Hibernate simplify complex application development. The ecosystem is mature and battle-tested. Critics point to Java's verbosity. Simple tasks require lots of boilerplate code, slowing development. Performance-wise, it falls between interpreted languages and compiled alternatives due to JVM overhead. Some developers find its syntax dated compared to modern languages. Here's a wild fact. Brendan Eich created JavaScript in just 10 days back in 1995 while working at Netscape. Originally meant to add simple interactivity to web pages, it evolved into something far more powerful. JavaScript is unique. It's the only programming language that runs natively in web browsers. Every interactive element you click, every drop-down menu, every dynamic form, that's JavaScript at work. Frameworks like React, Angular, and Vue transformed JavaScript into a tool for building complete web applications. Then Node.js arrived, enabling server-side programming. Now, developers can use the same language for both front-end and back-end work. That rapid creation shows, though, JavaScript has quirks and inconsistencies that puzzle even experienced developers. Type coercion, asynchronous behavior, and the infamous "this" keyword create endless debugging sessions. The lack of strong typing leads to runtime errors, though TypeScript emerged as a solution. The ecosystem moves fast, sometimes too fast, with new frameworks appearing constantly. Technically, HTML and CSS aren't programming languages, but try building a website without them. Tim Berners-Lee created HTML in 1991 to structure web content: headings, paragraphs, images, links. CSS followed in 1996, bringing visual control, colors, fonts, layouts, animations. CSS determines how content looks. Together, they form the foundation of every website. HTML defines what appears. CSS defines how it appears. Modern CSS features like Flexbox and Grid make responsive designs easier, adapting seamlessly across screen sizes. The limitation? They can't handle logic or interactivity alone. For dynamic features, you need JavaScript or back-end languages. CSS can frustrate with browser compatibility issues and complex layouts. Large CSS files become unwieldy without proper organization. Back in the 1970s, IBM researchers developed SQL, Structured Query Language. Unlike other programming languages, SQL serves one specific purpose: managing data in relational databases. Its simplicity is deceptive. A few lines of SQL can query millions of records, filter data, join multiple tables, and generate comprehensive reports. From small business websites to massive banking systems and social networks, SQL powers data management everywhere. MySQL, PostgreSQL, Oracle, all major database systems use SQL as their primary language. If your company deals with data, you're probably using SQL. Complex queries with multiple joins and subqueries can become difficult to write and harder to read. Performance suffers with poorly optimized queries or massive datasets. SQL works great for structured data and tables, but struggles with unstructured data like images or videos. That's why NoSQL databases like MongoDB gained popularity. Rust is the newest language we're covering. Mozilla Research released it in 2010, created by Graydon Hoare, who wanted C and C++ performance with modern safety features. The innovation? Rust's ownership system ensures memory safety at compile time. Many bugs get caught before code even runs. No garbage collector needed. You get C and C++ speed with modern safety guarantees. Tech giants noticed. Microsoft, Amazon, and Dropbox adopted Rust for critical infrastructure. Developer surveys consistently vote it the most loved programming language. It's ideal for operating systems, game engines, and any performance-critical application. The challenge? Rust has a steep learning curve. Its ownership and borrowing system, while powerful, confuses newcomers, especially those from languages with automatic memory management. Compilation can be slower due to extensive compile time checks. The ecosystem is still maturing, lacking some libraries that older languages offer. Each programming language reflects different priorities and trade-offs. Python prioritizes simplicity and versatility. C offers raw performance and control. Java promises portability. JavaScript owns the web. Rust represents the modern evolution of systems programming. There's no best language, only the best tool for your specific task. Thanks for watching. Subscribe for more tech breakdowns, and I'll see you in the next one.